Good morning Year 7 and welcome to today's maths lesson. Let's start off with a quick starter, shall we? Can you work out 76 times 56? Can you then work out 3/4 plus 5/8? And then can you solve for me 3x plus 2 equals -11? Pause the video and have a go at those questions now, please. Okay, let's go through the answers. 76 times 56, I'm going to do the column multiplication. You can do the grid if you'd wish, or the Napier method, up to you. 6 times 6 gives me 36. 7 times 6 gives me 42, 43, 44, 45, so I've got 456. Then going on to my tens column, I add a 0. I've got 6 times 5, which gives me 30. 7 times 5 gives me 35, plus 3 gives me 38. I then sum my two answers together. 6 plus 0 gives me 6. 5 plus 0 gives me 5. 4 plus 8 will give me 12. And 3 plus 1 gives me 4. I'm trying to add two different fractions here. Dejan, if I've got two fractions, I want them to add together, what do I need to do first? Make the denominator the same, very wise. So I'm going to make both denominators 8. Now the first one is already 5/8, so we don't need to do anything with that one. But the second one, to go from 4 to 8, we've got to multiply by 2. Whatever I do to the bottom, I've got to do to the top. So this is going to give me 6/8. So 6 plus 5 gives me 11/8. Daisy May, can you tell me what 11/8 would be as a mixed number? Brilliant, 1 and 3/8. I haven't specified either of those answers. I would mark as correct. And finally, I've said, can we solve 3x plus 2 equals -11? I want to get all my x's on one side and all my numbers on the other. I'm going to write it over here so that I can do it step by step. I've got 3x plus 2 equals -11. Rosie, how can I get rid of this plus 2? What do I need to do to both sides? Brilliant. I want to take away 2 from both sides. To get rid of that plus 2, I take away 2 from both sides, which leaves me with 3x equals -13. And then Drew, what's my final step? If I know 3 lots of x is -13, what do I need to do? Divide by 3, very wise. Dividing both sides by 3 tells me that x equals -13/3. You could have left that as a fraction, or you could have done it as a mixed number. As a mixed number, that would give me -4 1/3. I've left that in there so that you can notice that sometimes when you're solving equations, you may get a fraction as an answer, and that's okay. If you've done all the steps correctly, you may end up with a fraction. Moving into today's lesson, let's have a look. I've looked at two quadrilaterals. I've got an example here in the green, and I've got a non-example in the red. Elliot, what can you tell me about a quadrilateral based on my example of a quadrilateral and my non-example of a quadrilateral? So this one isn't a quadrilateral. Great, we've got to have 4 sides. The non-example's got 5 sides. We need to have 4 sides. So that's part of my definition of a quadrilateral. Here we go, I've got 2 more examples of quadrilaterals, so this time they're both examples, they're both in green. Trenton, what can you tell me about a quadrilateral based on these 2 examples? Absolutely, the lengths can be different. As long as we've got 4 sides, the lengths can be different of all those sides. And the angles can all be different, and it's still a quadrilateral. So we can have angles that are different, and we can have lengths that are different. and they're still quadrilaterals. In your dark blue books, can you write quadrilateral in the middle of your page, and then can you surround it with what you think the definition of a quadrilateral is, any characteristics, any examples you can think of, and any non-examples, so things that aren't quadrilaterals. In your dark blue book, pause the video for 5 minutes and have a go at that now, please. So this is what I came up with. I came up with a quadrilateral as being a plane figure that's got 4 sides and 4 angles, as quad means 4. I've said the characteristics: the 4 sides may or may not be of equal length, and they may or may not be parallel. I've got some examples down here in the bottom left and some non-examples in the bottom right. Yours may look slightly different, but make sure you've got something in each of these boxes in your dark blue books. Okay, Year 7, have a look at this shape. What can you tell me about it? Trenton, what can you tell me about this shape? Great, these 2 sides are the same length. Elliot, what else can you tell me about this shape? Splendid, these 2 sides are the same length. Notice that I'm using these little lines to indicate which sides are the same length. So these bottom 2 are the same length and the top 2 are the same length. What else can you tell me about this shape, Lucy? It's a quadrilateral, absolutely. It's got 4 sides. So, in your light blue books, can you name this shape? Is it a parallelogram, is it a kite, or is it a rhombus? Okay, Year 7, this one is a kite. So we've said it's got 2 sides that are the same here, 2 sides that are the same here. It's a kite. Here was my previous shape, that was my kite. What's changed about this shape that I've now got on the board? Charlie, what's different about this shape? Bang on, Charlie. Every single one of the sides of this shape is the same length. What else is true about this shape, Abby? Great, these opposite angles are the same. So this angle is the same as this angle. And this angle here, which I'm going to indicate with a double angle, is the same as this angle. So we've got 2 pairs of opposite angles that are the same, and all 4 sides are the same length. In your light blue books for me, Year 7, name this shape. Okay, this one is called a rhombus. So it's a rhombus when all the sides are the same length and opposite angles are the same. Note how it differs to the kite that we looked at earlier. Let's do another one. What's changed about this shape? What's changed about this shape, please, Dejan? Great, this shape, this side and this side are the same length, and this side and this side are the same length, but not all sides lengths are equal. What else can you tell me about this shape, Jack? Ace, the opposite angles again are the same. This one and this one. Okay, Year 7, light blue books, name this shape for me. Splendid, this one is a parallelogram. Note how it differs from our kite, where we had 2 sets of different length sides, but the opposite angles weren't the same. This time we've got 2 opposite sides that are the same and 2 sets of opposite angles that are the same. In your light blue books, pause the video for a couple of minutes and match the correct shape with the angle properties. Pause the video and have a go at that now, please. And here are the answers. Please check your work and see how you did. Okay, Year 7, in your dark blue books, can you copy this out for me, or a variation of your own? Can you draw me a diagram of each quadrilateral and write down which angles are the same? For example, in a rectangle, all the angles are equal. In a square, all the angles are equal. In a kite, we've got 2 opposite pairs of angles, one opposite pair of angles that are equal. In a rhombus, we've got 2 opposite pairs of angles that are equal. In a parallelogram, we've got 2 opposite pairs. And in an arrowhead, a pair of angles are equal, these bottom pairs. Can you also make sure you've got the correct notation on each of the sides, indicating which sides are parallel or the same length. Pause the video and complete that now, please, in your dark blue books. Okay, Year 7, ABCD cards, or light blue books. Joe and Paul are arguing about the precise definition of a rhombus. Joe says with a rhombus, all sides are equal length and opposite sides are parallel. Paul says a rhombus has diagonally opposite angles that are equal. Who's correct? Pause the video for a minute, have a think. Okay, Year 7, ABCD cards, or light blue books. Can I see A, can I see B, can I see C, or can I see D? Great, I was looking for C. They're both correct. In a rhombus, all sides are equal length. Opposite sides are parallel, so this top side is parallel to the bottom side. Let's label it up. And these sides on the left and right hand side are also parallel. We've also got diagonally opposite angles are equal. Let's change colour. This angle here is the same as this angle here, and this angle here is the same as this angle here. Okay, moving on. What do the angles in a triangle add up to? Robert, what do the angles in a triangle add up to? Great, 180 degrees. I agree. Here's my triangle. We know that the angles will add up to 180 degrees. How about this triangle, Daisy? What do the angles add up to? Brilliant, we've just flipped the triangle over. Still adds up to 180 degrees. Nothing's changed. So how about now? I'll put those two triangles together. What do you reckon the angles add up to this time? Have a little think. What do you reckon? Edie, what are you thinking? Right, this time we've got 180 degrees in this one. We've got 180 degrees in this one. So all of those angles are going to add up to 180 plus 180, which gives me 360 degrees in this rectangle. We could also think of it as 90 plus 90 plus 90 plus 90. But does this work for all quadrilaterals? We said a quadrilateral was any shape with 4 sides and 4 angles. But we didn't say they had to be the same length. We didn't say we had to have right angles. So you could split up any quadrilateral into 2 triangles like so. So I've got a wonky quadrilateral here and I've split it into 2 triangles. Daisy May, what's the sum of the black angles in my quadrilateral? Great, 180. Splendid. Jake A, what's the sum of the white angles in my quadrilateral? Great, 180. So the sum of the interior angles of any quadrilateral are 360. Doesn't matter what that quadrilateral is, always going to be 360 degrees. And you can see why by the fact that we can divide any quadrilateral into 2 triangles. Okay, dark blue books out, Year 7. Can I have the title Angles in a Quadrilateral? Underneath it, can you write the angles in a quadrilateral add up to 360 degrees? And then can I see pens down and eyes on the board? I'll go through an example and you're going to do an example. Right, I'll go through the one on the left. I've asked, what's the name of this shape? Can anyone tell me what's the name of this shape? Have a little think and look at it. What is the name of this shape? Rosie, what's the name of it? It is a parallelogram. Wicked. And we know this because it's got 2 opposite pairs of angles that will be the same and 2 opposite sides that are the same length as well. Good spot. We need to work out the missing angle A. We know that the angles in a quadrilateral add up to 360. So to work out what A is, we need to do 360, take away 115, take away 115, take away 65. which gives me what, Ludo? $65, lovely. And that makes sense with what we know about a parallelogram. We know that opposite angles are equal, so this makes logical sense. The missing angle will be 65, the opposite to this other 65. Okay, Year 7, in your dark blue books, can you have a go at this example for me? Pause the video for a minute and work out what E is. Okay, let's go through the answer. This time we've got E is 360, take away 120, take away 65, take away 80. So hopefully in your dark blue books you will have got 95 degrees. Okay, Year 7, can you pause the video for 5 minutes and have a go at these 4 questions for me? Work out x in each case. You may use a calculator if you need, you probably don't need one. And these are the answers, please check how you did. Okay, we're all at different stages of understanding on this topic. Can you now pause the video for about 10 minutes and have a go at as many of these questions as you can in your light blue books? Pause the video now. And here are the answers, please check how you did. For those that are confident, can you pause the video now and spend 5 minutes on this extension question using a little bit of algebra, but still knowing that there are 360 degrees in each quadrilateral. Don't worry if you're completely lost now, this is an extension piece. And these are the answers for those that solved it. This time I've added together everything within this quadrilateral, so that's given me 45 take away 5 leaves me with 40. I've got 10 lots of x, so I've got 4x plus 3x plus 3x, which gives me 10x, which is 360, as I know that all the angles in a quadrilateral add up to 360. And then I've solved that equation, as we've been doing, to give me x is 32. In the same way, I've got x is 80, x is 31, and x is 40. Okay, Year 7, can you have a go at this one for me now? Pause the video for a few minutes and have a go at it in your light blue books for me. Find the missing angles. And these are the answers, please check how you did. And finally, Year 7, if you're super confident, can you pause the video and have a go at this? Please remember that the angles in a triangle add up to 180, angles in a quadrilateral add up to 360, angles in a straight line add up to 180, and angles around a point add up to 360. You're going to need all of those facts to complete this work. And these are the answers. Please check your work and see how you did. And that's the end of today's lesson. Can you now head over to Google Classroom and complete today's exit ticket for me? Hope you have a lovely day and thanks for listening. Goodbye.